you've been following this topic for a while, Alas, this idea was not sensationalized by journalists, rather, it originated from statements made by Kat Sagan and Frank Drake. Like many scientists, they believe our planet is nothing special, so life could be abundant throughout the universe. This perspective is even referred to by a specific term, the principle of triviality. Once again, we cannot help but wonder, where is everyone, really? Be sure to watch both parts of the film in full so you can fully understand our journey to explore extraterrestrial life. Sincerely thank you for your companionship. Everything is much more complicated than I thought. Thanks to the work of several researchers, the triviality principle has infiltrated popular scientific discourse without encountering any scrutiny. Until a few years later, you'll notice that discussions on this topic are not as numerous as they should be. Recent discoveries have ultimately compelled us to re-examine the principle of mediocrity. However, if this principle is somewhat inconvenient, its alternative is far worse. It creates a feeling of utter, hollow loneliness, allowing one to understand both despair and hopelessness. We might just be the result of such a fortunate coincidence that, simply put, we are merely one of countless possibilities within this entire universe. This idea evolved into a groundbreaking hypothesis known as the rare earth hypothesis. The research by Walt Petady and Donen Brawley raises the question, why is complex life not more common in the universe? In the bookstore, they delved deeply into this issue and presented incredibly compelling arguments to explain it. Why is complex life so unimaginably rare, perhaps even unique? This unique phenomenon can only occur due to a rare coincidence of specific astronomical and geological conditions. According to this hypothesis, a planetary system capable of sustaining complex life must have a structure similar to that of the solar system. The smallest change can destroy everything, which is what many people often refer to as the butterfly effect. The habitable zone. This is almost a prerequisite for life to be able to form. The habitable zone is the region around a star where conditions on the surface of orbiting planets could allow water to exist in liquid form. In our case, the uniqueness is also reflected in the fact that Earth's orbit is nearly circular. Throughout a year of orbital motion, we do not perceive the distance from the Earth to the Sun as being too far or too near. But that is only the beginning. As we delve deeper into the issue, we will discover more and more conditions that are not widely known. However, it is not only star systems that possess habitable zones. Our Earth is also a fortunate planet, located within such an ideal temperate zone of our galaxy. Entirely clear yet, therefore, our solar system takes approximately 235 million years to complete one orbit around the center of the Milky Way galaxy. This means that since the oceans formed, our planet and the Sun have traversed that region of space 17 times. Since the first true signs of life emerged, Earth has undergone 15 mass extinctions, and since the first multicellular organisms appeared, there have been 7 such events. It was never an easy battle. Even when you gaze into the space between the stars, all you perceive is a vast emptiness. On its journey across the galaxy, our tiny solar system will encounter countless unforeseen surprises. They can be fatal to entire ecosystems, and even to our planet. Furthermore, it is also the largest known dead zone ever recorded. The land of disbursement is a region incapable of sustaining complex life or giving rise to any life forms. Why is that? As we approach the center of the galaxy, the destructive power of cosmic rays intensifies. The gamma radiation emitted from the jets of black holes and neutron stars becomes increasingly more intense. The closer you are to the galactic center, the more frequently supernovae occur nearby. These are weapons of mass destruction, capable of sterilizing entire worlds even from light years away. Additionally, its proximity to the center also increases the risk of attention-grabbing disasters. Even if a planetary system has rather unfavorable conditions, it still requires a passing star. Or worse yet, it could be a black hole, which would tear apart and devour everything. At that time, we could already recognize that basic mathematics does not make claims such as there being hundreds of billions of stars in the Milky Way, or even more than that. This means the assumption that the Milky Way must be teeming with life is fundamentally flawed. Most stars are concentrated near the center of the galaxy, a region of intense and violent activity. Even if life could form there, it would struggle to survive. At the same time, being too far from the galactic center is not ideal either. The greater the distance to the center, the lower a star's metallicity becomes. This is one of the key factors for the formation of planets with characteristics similar to Earth. Recent studies indicate that the habitable zone within the galaxy spans from 7 to 9 kiloparsecs in length, located approximately 22.8 to 29.4 thousand light-years from the galactic center. Surprisingly, even by the most optimistic estimates, we have no more than 10 such stars in this region of the Milky Way. However, time is the crucial factor. It takes billions of years for a planetary system to form under the right conditions, and, most importantly, to sustain life. Therefore, an ideal planetary system must have a stable orbit around the galactic center to ensure it always remains within the habitable zone, even during brief periods. Strange, look. The Sun lies precisely within the habitable zone of the entire galaxy. Its orbit is almost perfectly circular. But this place holds even more secrets. Our Milky Way is actually quite a rare phenomenon. For 10 billion years, it has almost never existed as a separate galaxy, nor has it ever collided with any other galaxy. Remember that our entire universe is just over 13 billion years old. This is also part of why the galaxy is such a quiet place, like a peaceful and safe harbor. We have only observed 7% of the galaxies in the universe. Now let's recall one thing. Our own Milky Way is currently moving at a considerable speed toward its nearest neighbor, the Andromeda Galaxy. A collision is perhaps almost certain. It will be an excellent filter for our civilization. However, this event will not occur for at least another 4 billion years. However, if humanity proves so incompetent as to be incapable of venturing into deep space exploration within the next 4 billion years, they would face extinction for countless other reasons anyway. Let's move somewhere else. When gazing at the stars scattered and shimmering across the night sky, we sometimes think that among them, there must be stars similar to our own Sun, aside from differences in size and brightness. However, that thought is completely untrue. According to various estimates, about half of the stars in our galaxy exist in binary star systems. A prime example is the Alpha Centauri system, which in fact consists of 3 stars engaged in an intricate orbital dance through space with unpredictable trajectories. In science fiction films, we are often treated to vibrant scenes, with sunsets or sunrises featuring 2 or 3 suns on the distant horizon of some alien planet. However, there are many reasons why planets in such systems are unlikely to become cradles of life. The likelihood that these planets could maintain stable orbits for billions of years is very low, making the issue of defining the habitable zone far more complex. But there's no need to speculate that far, because however ordinary it may seem, the Sun actually possesses extremely rare characteristics. Our star exhibits remarkable stability, with its brightness fluctuating by only about 0.1%. Although many stars similar to the Sun have been discovered, no known star possesses an exact match in mass, luminosity, temperature, age, and metallicity. Each of these factors plays a crucial role in the overall equation, determining whether life can exist. Our solar system holds many mysteries, such as the peculiar structure and unique positioning of the gas giant planets. S presence is considered a blessing, as it stabilizes Earth. But even if you add up all these minuscule probabilities, the chance of any of them occurring still cannot approach the threshold of practical reality. It completely changes our perception of the boundary between the possible and the impossible. We are not discussing the origin of life or the process of evolution. As we know, even if things become easier and we accept the panspermia hypothesis. If we assume that life on Earth originated from some star, then the origin of life itself would still remain an unanswered question. Survived 2 major ice ages that occurred 2.2 billion years ago and 635 million years ago. Who would have thought that those 2 seemingly catastrophic events were actually favorable conditions for the evolution of life? The first event that spurred the development of microorganisms capable of photosynthesis, significantly reducing greenhouse gas concentrations and promoting oxygen accumulation. After the Second Ice Age, the legendary Cambrian period occurred and gave rise to most of the rapid evolutionary developments we see today. Thus, the first brain emerged, unveiling a dramatically rich historical panorama. Along with complex ice ages and mass extinction events, they helped shape the course of evolution and the complexity of life forms. If we were to find a hypothetical planet with ideal conditions, just like paradise, it is very likely that it contains life, or perhaps it is simply too primordial. Therefore, no complex task requires excessive effort to resolve. There's no need to complicate things, just let it develop naturally under ideal conditions, like in paradise. Everything around you is easy and comfortable, so why would you want to evolve into a more advanced version? Therefore, no matter how cruel it may sound, those contrasting conditions are truly necessary for the process of evolution. Favorable factors alone are not sufficient. They must be balanced with opposing conditions such as day with winter, night with summer, the divider with the reconciler, life with death, and so on. While it may sound harsh, this is an academic truth. The evolutionary process itself provides evidence for this conclusion. It is often said that one should not be overly pessimistic about misfortunes, for life is already fragile enough. How many elements does this kaleidoscope of colors need to arrange to form a sequence of events? From a barren and lifeless planet, it evolved into a high-tech civilization with the capability to conquer space. Please note that we are operating under the assumption of the panspermia theory. Life on Earth is inherently perfect, but if we are honest with ourselves, perhaps we must transcend it. Ultimately, life must have emerged somewhere, somehow. Suppose somewhere in the universe, there exists a point where all favorable conditions, no matter how improbable, converge completely. The habitable zone is where there is a perfect combination of the host star's parameters. A rocky planet with the presence of water and an atmosphere. A perfect twin of Earth is hiding somewhere in the depths of the universe. Therefore, the first foundational brick that modern science uses to construct the concept of life is a complex molecule capable of self-replication. Only when the first self-replicating body appeared did the mechanisms of evolution truly begin to operate. But that very first replication mechanism itself must have arisen randomly. The problem is this: even the simplest replication mechanism is too complex to arise entirely by chance. Scientists have conducted countless complex computer simulations to study this topic. The results obtained raise more questions than they provide answers. Scientist Engelop Kunin, an international expert in evolutionary and computational biology, holds dual American and Russian citizenship. The probability of the spontaneous emergence of the first replicating organ has been calculated. He stated that the number is 1 multiplied by 10 to the power of 10 to the power of 18, meaning it's a 10 followed by 10 to the power of 18 zeros. Did you know that the total number of atoms in the universe is estimated to be around 10 to the power of 80? Yet, that colossal number is still equal to 0 when compared to 10 to the power of 1018. Basically, this ratio is incomprehensible. Even a distinguished scientist like Kunin ultimately had to resort to the hypothesis of dark energy in the universe to explain it. Somehow, this inexplicable number simultaneously elevates the role of science. Kunin reminds us that such a conclusion is indeed overly simplistic. By the year we let soldiers perform scientific research, we'll have to lower the standards for families. And ruthlessly cut away the unnecessary with Occam's razor. Unfortunately, dreamers may be disappointed by his conclusion that the emergence of life requires a series of exceptionally rare events. Therefore, we are alone in our own universe. We are not merely intelligent beings, but above all, we are the only living creatures in this vast universe. Everything operates based on cold, mechanical calculations. This cruel statement may not yet be the final verdict for those who dream. Today, the emergence of artificial intelligence appears to be becoming yet another barrier that humanity struggles to overcome. This is an extremely complex issue, but no less fascinating. Although the rare Earth hypotheses have faced considerable criticism, the main opposing arguments focus on a few very specific, detailed points. Therefore, if we can recognize the situations a person is facing, however, it remains very difficult to refute it with another alternative that is, to some extent, meaningful and rigorously argued. But the truth is even harsher. Humanity has witnessed thousands of UFO encounters, sent humans to the moon, and landed robots on Mars. After many years of listening to the universe through radio telescopes, we have discovered thousands of exoplanets. They even launched a spacecraft that flew out of the solar system. Therefore, for the past 100 years, we have been continuously sending signals into space. We have even actively sent naive, highly audacious signals into space, aimed at extraterrestrial civilizations. We also connect thousands of space enthusiasts on the internet to collectively decode signals received by the Arecibo Observatory in Puerto Rico. As part of the legendary SETI program, everything remains silent, no signals have been detected. Even as the Arecibo radio telescope collapsed catastrophically, none of them seemed to pay it any mind. Not a soul in sight, no one came at all. But no matter how hopeless this absolute silence may seem, it is not a verdict. It was Kasagin himself who repeatedly emphasized that, with his characteristic way of thinking, the absence of evidence is not evidence of absence. If the panspermia hypothesis is correct, then life may not have originated solely on our planet. This will change the entire landscape and completely reverse the current argument. Finally, all those low probabilities seem to hold no significant meaning. The search for extraterrestrial life is a journey without end. Moreover, intelligent civilizations possess a significant vulnerability. We can never truly know which elements and which chain of transformations have created life's miraculous formula. And we don't even fully understand what true intelligence is and what forms it might take. So why do we persist in believing that only human intelligence has existed on Earth all this time? We are always searching for ourselves, yet in reality, even whether we truly exist remains uncertain. Life must necessarily be built upon a foundation of carbon. Every one of them is, to a greater or lesser extent, concerned with this subject. They heard of hypothetical life forms, but they, for example, when subjected to an extremely high pressure, approximately 460,000 gigapascals. Nitrogen and hydrogen compounds are even more chemically diverse than hydrocarbons. Therefore, it can be reasonably inferred that our derivatives are more diverse and abundant than all existing synthetic compounds. Here, we are just one step away from creating a hydronitric knife as a replacement. You can find suitable conditions for biochemical processes like these at a certain depth inside giant planets. Only a large amount of nitrogen and hydrogen under high-pressure conditions. But that is an entirely different story, and also a different series of killings. But we are still actively searching for ourselves, and doing so consciously in this manner. At the very least, we have some clue about what we're looking for, since how can one search for something vague without even knowing what it is? You have absolutely no idea about that. We have discussed this topic at length, so let's be honest with ourselves. We are not searching for just any civilization.